This video guide will cover the first page of your balancing formula equations packet. Okay, in number one, we have potassium oxide combining with water to yield potassium hydroxide. So the first thing I would do is I would complete an atom inventory. So I would kind of divide this up, and over here on the reactants, notice here I've got 2 potassium. I actually have 2 oxygen as well, because I have 1 oxygen here and 1 here. So when you have them between 2 compounds, you have to add them together. So this would give us 2 oxygen, and then of course right here we have 2 hydrogen. And so that is our complete inventory for the reactant side. If you look over here on the product side, we have 1 potassium, 1 oxygen, 1 hydrogen. And so this one's actually fairly straightforward. As you guys are already aware, the only thing I can do is add coefficients. So that means I can add a number here, a number here, or a number here. So a whole number that goes in front of the compound that applies to everything in it. I can't change subscripts, I can't add them, I can't alter them, I can't erase them. Alright, so the only thing I can do is add a number either here, here, or here. And so if you look at that, well, I can easily balance this by putting a 2 in front of the potassium hydroxide. The potassium becomes 2, oxygen becomes 2, hydrogen becomes 2. Notice everything is balanced, everything is equal, so the coefficients that you have are essentially 1, 1, and 2. Okay, in number 2, we have the decomposition of hydrogen peroxide, and it looks like it's turning into water and oxygen. So once again, as always, we're going to do our atom inventory, so keep them kind of separate here. On the reactant side, it looks like we have 2 hydrogens and 2 oxygens. The subscripts apply to the element in front of them. For the products, it looks like we have 2 hydrogen, and then notice we have 1 oxygen here and we have 2 over here, and because they're in different compounds and we're adding them, 1 plus 2, we have a total of 3. Okay, so in looking at this, the hydrogen looks good. Oxygen, I have 2 and I have 3. Normally when you have 2 and 3, a common factor you would want to use is 6. However, I'm going to give you a little tip here. Anytime you have 2 and 3 and the 3 are separate in a group of 1 and a group of 2, that means the atoms aren't all together, the common factor is not going to be 6, which you would anticipate. The common factor ends up being 4. That's just something you would have to remember. Okay, in order to get 4 oxygen on the left, I'm going to put a 2 in front of here, and then what's going to happen, this 2 times this 2 will end up giving us 4 hydrogen, and likewise this 2 and this 2 will end up giving us 4 oxygen. So 4 of each. And the product side, if I put a 2 in front of the water, 2 times 2 is going to give us 4 hydrogens. And then notice if we have 2 times this 1, there's 2 oxygen here, with 2 more over there that we have to add in. Well, lo and behold, that gives us our 4. So the coefficients you needed were 2, 2, and leave that one at 1. Okay, for number 3, we have aluminum reacting with oxygen, and it looks like it's forming aluminum oxide. So, as always, let's start with our atom inventory. On the left side, we have 1 aluminum, and we have 2 oxygens. Looks like on the product side, we have 2 aluminum, and we have 3 oxygen. Okay, the first thing I'm going to mention to you, when you look at this, you might say right away, okay, I should probably put a 2 here. That way it will balance the aluminum. However, here's another free tip. Anytime you see an element like this all by itself, so it's not bonded with anything, it doesn't even have a subscript by it, so it's just an aluminum by itself, I'm going to leave that element alone until the very end, because that is very easy to balance. No matter how many aluminums I end up with over here, say I ended up with 17, well, very easy. I would just put a 17 here, and it would be balanced. So anytime you have an element, like I said, all by its lonesome, try to leave that until the very end. You'll thank me later. All right, so we're skipping the aluminum. Let's look at the oxygen. I have 2 and 3. Unlike last time, you'll notice the 2 and 3 and the 3 are all in one place. Well, when the 3 are all together, the common factor you're going to want to use is 6. How am I going to get 6 oxygen on the reactant side? Well, if I place a 3 here, 3 times 2 will give me 6. On the product side, if I put a coefficient of 2 here, this 2 times this 3 will give me 6 oxygen as well. And now the number of aluminum, 2 times 2, I now have 4 over here. Well, I can easily balance that by putting a 4 here, and it's balanced, so the coefficient should be 4, 3, and 2. Alright, number 4 was actually a little challenging. It's kind of a goofy one, so if you had trouble with this one, don't feel bad. It causes most people problems, especially ones who are just kind of learning this skill. So just as always, we're going to do our atom inventory. So I want to count. Well, it looks like on this side, let's see, we have 2 sodiums. Oxygens, I have 2 here and I have 1 here. So that means I have a total of 3 oxygens. And then in the water there are 2 hydrogens. And so that's my atom inventory. I'm going to follow the same pattern over here. I have 1 sodium present. Looks like oxygens, I do happen to have 3 because I have 1 in the sodium hydroxide and 1 in the, or excuse me, 2 in the oxygen, so 1 and 2 is 3. Hydrogen, I only have 1. Okay, excuse me. All right, so let's take a look. 2 sodium on the left and only 1 on the right, so if I place a 2 here, my sodium becomes 2. My oxygen, now I have these 2 here plus these 2. So now I have a total of 4 we need to account for. And then hydrogen, 2 times 1, that gives me 2. So if you look at this, we've kind of got ourselves in a problem because the sodium looks good, the hydrogen looks good, the oxygen does not look good. And unfortunately, there's really not any oxygen by itself to kind of, manipulate so that it makes it easy to balance. Except there kind of is one by itself. If you look over here on the end, there is an oxygen, even though it's diatomic. And so you may say to yourself, well, Self, that's not going to help me. Because if you look at this, if I put any numbers in front of here, it's only going to make this number bigger, and I need it to be smaller. Well, if you think logically about this, if there was some way that I could just take that 2 and get rid of it, then it would be balanced, because then I would have 3 oxygens. Unfortunately, you can't do that. So this still has to be O2. Sorry, you'll have to pretend it's down there. So anyway, so it's like if there's only way we could get half of that O2. Well, there is. We could put a coefficient of 1/2 here. The problem is that we can't use halves. The coefficients always have to be whole numbers. How do I get rid of a half? Easy, I double it. And so 1/2 doubled is just 1. And if you double 1, you must double everything. This is going to become 4. This number 1 becomes a 2. This number 1 becomes a 2. And so now that's balanced. Let's check it. Over here, I have a total of 4 sodium. Here's 4 sodium on this side. Oxygen, I have 2 times 2 is 4, plus these 2, which is 6. Well, here's 4 oxygen here. Here's 2 more here, so there's 6. Hydrogen, I have 2 times 2 is 4. Here is 4. This is now balanced. Okay, this looks like number 5. We have silicon dioxide, and then that's hydrofluoric acid will make silicon tetrafluoride, and it looks like water. Okay, so as always, we're going to do our atom inventory. So I want to take my, let's see, I have 1 silicon, I have 2 oxygens, looks like 1 hydrogen, and 1 fluorine. I'm going to do the elements in the same order over here. I only have 1 silicon over here. Oxygen, it looks like only 1. The hydrogen, there are 2, and it looks like we have 4 fluorines. So there's our correct inventory. Let's see, starting out, silicon looks good. Oxygen, I have 2 on one side and 1 on the other. I can fix this if I put a 2 in front of the water. And let's see, so that's going to change my hydrogen to 4. And let's see, my oxygen then becomes 2. Okay, well, Fortunately, it looks like we got lucky because now I have 4 hydrogen and 4 fluorine, and they're together on the reactant side with only 1. So if I put a 4 there, this becomes 4, this becomes 4. It's balanced. So the coefficient should be 1, 4, 1, 2. Okay, and number 6, atom inventory. On this side, the left reactant side, it looks like we have 1 atom of carbon. There appear to be, oops, it's not picking that up, there's 2 hydrogen, and it looks like 1 oxygen. On the product side, 1 carbon, it has 2 hydrogen, and lo and behold, 1 oxygen. This one is already balanced. That happens on occasion. You didn't make a mistake if you have that come up, you don't think, oh, I've done something wrong. That does occur on occasion. It's not super common, but it's not so uncommon you never see them either. So sometimes just in nature, everything occurs in a 1-to-1 ratio, and you come up with a situation like this. So already balanced for this one. Alright, in this problem, it looks like we have potassium chlorate. It's breaking down, turning into potassium chloride and oxygen. So, atom inventory, let's do it. Over here I have 1 potassium. It looks like I have 1 chlorine, and I have 3 oxygens. You may note, yesterday I told you, if you have a polyatomic, usually it's a good idea to leave it together if you can. In this case you can't, because notice chlorate does not exist in this form. The chlorine and the oxygen break apart. So you have to separate this into its constituent elements, into chlorine and oxygen. So on the product side, it looks like I have 1 potassium. Let's see, the chlorine looks like there is also 1, and the oxygen, it appears like we have 2. So the potassium and the chlorine are good, the oxygen is not. I have 2 and I have 3. The 3 are all together, so I'm going to use a common factor of 6. If I put a 3 there, that turns this into 6. If I put a 2 here, this oxygen becomes 6. And lo and behold, I also change the potassium and the chlorine. That's easily remedied by placing a 2 in front of the potassium chloride. So the coefficient should be 2, 2, 3. Okay, here's a different reaction, also involving the breakdown of potassium chlorate. This time it's turning into, it looks like potassium perchlorate and potassium chloride. But no worries, atom inventory as always. Okay, there's 1 potassium, there's 1 chlorine, there are 3 oxygens. On this side, okay, if I have 1 potassium here and 1 here, there are a total of 2. The chlorines, it looks like there are also 2, and the oxygen, it appears that there are 4. Okay, so let's take a look at this. Let's see, if I have 1 and I have 2, I can probably remedy that by placing a 2 in front of here. That's going to give me 2 potassium, 2 chlorine, and it's going to actually make 6 oxygen. I was able to fix both the potassium and the chlorine pretty easily, but now you're going to see we've kind of ran into a problem, because if you look at the oxygens, I have 6 and I have 4. Really this isn't the time to really fret. If you think about this, there's a couple of ways you can go about it, but either way it's going to lead you to the same thing. Obviously I probably don't want to start with the potassium chloride, and that's okay. So if I want to do the oxygen, I can either look at it the way we have it now, 6 and 4, or you can go back and look at the original 3 and compare it to 4. Either way, it doesn't matter, you're going to come to the same conclusion. A common factor that both 3 and 4 go into, or even 6 and 4, the first number that all those numbers have really in common is going to be 12. And so in order to get 12 oxygens, I don't want a 2 here. I want to put a 4. And that's going to change this to 4. This becomes 4. And then 4 times these 3, there are 12 oxygens. Likewise on this side, if I want 12 oxygens, I need to place a 3 in front of the potassium perchlorate. So if I have 3, if I end up with 3 potassiums here and 1 here, well, 3 plus 1, I now have 4. Same thing with the chlorine, 3 plus 1, there are 4. And then for the 3 times 4 oxygens, there are 12. There are your coefficients. So they should say 4, 3, and 1. Okay, you'll have to forgive me on this one. I mean, I can't write that small on the iPad, so what I did is I actually just kind of separated it, moved it a little bit so I could get the reactants and products both on the screen. So I'm going to do the atom inventory just as before, so that's why you see this weird formatting. One other thing I want to mention to you, okay, I've mentioned this a little bit before, I kind of mentioned this, but if you see a polyatomic ion, so these many atoms that are bonded together that form an ion, a charged particle, if you see them on both sides, it's much easier most of the time to leave them together. And so here's an instance. I see sulfate as a reactant and a product. I'm going to leave it together. Likewise, if you look at the hydroxide, there's a hydroxide on the left, there's one on the right. So if you see the same polyatomic ions, the same group of atoms, leave them together. It makes your life much easier. So let's do our atom inventory. Okay, so it looks like in this case I have, looks like 2 aluminums. When you look at the sulfate groups, there aren't 4 sulfates, it's this number outside here. So there are 3 of everything in here. There are 3 sulfate groups. So you want to write that as 3 SO4s. It looks like I have 1 calcium, and likewise I have 2 hydroxides. So just like before, same type of deal. Let's do our other inventory over here for the product side. It looks like I have 1 aluminum. The sulfate, it appears there is 1 sulfate. With the calcium, it looks like there is 1. And then finally, the hydroxides, it appears that I have 3. Okay, I'm going to just jump right in. If I have 1 aluminum and 2 aluminum, if I put a 2 here, the aluminum becomes 2, and then 2 times 3, my hydroxide becomes 6. Okay, not a huge deal. Let's look. Sulfates, I've got 3 and I've got 1. If I place a 3 here, my calcium becomes 3, my sulfate becomes 3. All right, well, so I have my aluminum fixed, my sulfate fixed, I have 1 calcium and I have 3. If I put a coefficient of 3 in front of here, this becomes 3, and then 3 times 2, my hydroxide becomes 6. So the coefficient should be 1, 3, 2, 3. All right, in this example, it looks like we have tetraphosphorus decoxide combining with water, and it's making phosphoric acid. You don't know how to name acids yet, but that's okay. Let's do our atom inventory. It looks like on the reactant side, we have a total of 4 phosphorus, and then there are 11 oxygens, because there's 10 here, and don't forget that guy, so you have to sum them, and it looks like there are 2 hydrogens. On the product side, it looks like phosphorus, I have 1 phosphorus only. The oxygen, it appears we have 4, and then we have 3 hydrogens. So just kind of keeping those in the same order. Okay, let's take a look. If I have 1 and I have 4 as far as the phosphorus goes, if I put a 4 here, that's going to make my phosphorus 4, and at the same time my hydrogen is going to become 12, and my oxygen are going to become 16. All right, the next thing I'm going to look at, if I see the numbers 11 and 16, those numbers do not jazz me up. They probably don't jazz you up either. If you try to think of a common factor both 11 and 16 will go into, it's probably 11 times 16, and I don't think we really want to do that. And so it's okay to skip and come back. If you look at this one, this looks way easier. If I have 2 hydrogen and I have 12 hydrogen, wow. I mean, that's much simpler. So why don't I go that route? And a lot of times you'll find it fixes itself. Okay, how am I going to get 6 hydrogen over? Excuse me, 12 hydrogen. I need to put a 6 here. 6 times 2, that's going to give me 12 hydrogen. And look what just happened to our oxygen. I still have these 10, but I have these 6. 6 and 10 are, lo and behold, 16. So it actually fixed itself. So the coefficients in this one should be 1, 6, and 4. All right, last one. Okay, and here we have, it looks like iron 3 chloride combined with ammonium hydroxide, and it's turning into iron 3 hydroxide and ammonium chloride. So once again, let's do our atom inventory, and I've got it kind of, justified weird just so I can fit it in here and still write legibly. Let's see, it looks like I have 1 iron, and it looks like I have 3 chlorines. I have 1 ammonium. I'm going to leave that together because it's a polyatomic on both sides. And I happen to have 1 hydroxide. On the other side, it looks like I also have 1 iron. The chlorine looks like 1. The ammonium looks like 1. And then the hydroxide appears to be 3. And so, let's try to balance this guy. If I have 3 chlorines and 1 chlorine, if I put a 3 here, the ammonium becomes 3, the chlorine becomes 3. Let's see, if I want to get 3 ammoniums, I need to put a 3 in front of here. That's going to change this to 3, and it also changes the hydroxide to 3. Notice everything is balanced. The coefficient should be 1, 3, 1, 3. Thanks for watching.